All right, so integral is next, net change, 7.1. I don't know if anybody's ever been up to the Rainy River. Has anybody been to the Rainy River? So it's the river that bounds Minnesota with Canada. I used to go up there at least twice a year. This time of year, we'd go up there and try to catch walleyes, and you can catch walleyes until like mid-April up there. Everywhere else in the state is closed. But there's special rules, like you have to let everything go except for you can keep 219. I think it's 0 you can keep now, but the big walleye, the big females come into that river to spawn this time of year, so people go up. You literally have to walk a mile sometimes to get to the landing because that's how many boats, like trucks and trailers there are. So everybody goes up there, catches a bunch of big walleyes, takes pictures, and put them back in the water. So, and then we used to go up. Teachers used to go up and go sturgeon fishing then. Mr. Polkinghorn and his family. Anyway, the Rainy River, I looked at what's going on in the Rainy River right now up there, and it's not changing much because it's still bound by ice. So I'm like, well, let me grab a chunk of data. Oh, this is 2012. Actually, I looked yesterday in April 2020 with some pretty good stuff, but here February. Okay, so what we have here in the river is the cubic feet per second. So this is the rate in which the water is flowing.
You're not sharing your screen.
Okay, sorry. So if we have a series of rates, or you can call them velocities, could we figure out, from February 23rd to March 1st, how much, although I don't see a marker on the 20, oh, there isn't a 29th, that's here, probably. So we could figure out how much water is flowing in those 7 days. How could I do that? This is not how much water, this is how fast the water is traveling in cubic feet per second. So how could we figure out how much water actually flowed through the river at Manitou Rapids for this week? Carter, what do you think? Good. You find the area under the curve. If you have some sort of a water hydrometer to figure out how fast it's going, you can figure out how much water just by finding the area under the curve. So if you found all of those, well, so how could we find the area under the curve? What are some ways that we can do that we've learned so far? MRAM. So MRAM, LRAM, RRAM, those are all. So RAM is one technique. What's another technique? Trapezoidal, right. So you can find the trapezoid here to here to here to here to here. So that's 2 techniques. Good. A third technique. What else? Integrals, very good. So could we integrate this right here?
If we found a line of best fit, maybe.
Okay, so not necessarily a line of best fit. It could be a line. This doesn't look like a linear relationship. So some sort of a curve of best fit. I don't know what kind of shape this actually turns out to be. This looks like it could be a 4th degree polynomial. If you take this one and move it to like the next day, you could argue that this is a 4th degree polynomial, so a quartic of best fit. I'm pretty confident that we would not find an equation, a polynomial, that would go through all of those little triangles. So it would be a decent way of doing it. Not as good as using RAM or trapezoid, because that's just, our curve might go up like this and then down. It's just not a good representation. But yeah, that's a 4th way we could find the area under the curve. Whatever the area is, that represents the amount of water in those 7 days traveled through the Manitou Rapids. Okay, so let me give you a problem, and I want you to try it. So the velocity is t squared minus 8 over t plus 1 squared. Okay, so this is the velocity of a particle moving along a horizontal s-axis. So let's say if s of 0 equals 9, what is the particle's position at t equal to 1 and t equal to 5? So see if you can figure that out. I'll give you a couple minutes to do that. Okay, so we got 16 thirds. So you found the antiderivative, so that'll be the position. So s of t equals 1/3 t cubed. Is it just plus 8 over t plus 1 plus c?
Yeah. Yep.
Okay, so then we need an initial value. S of 0 is 9, so 9 equals 0 plus 0 plus 0 plus c, so c is 9. So then our position equation, is it 1?
Yeah, because if you plug in...
Oh, plug in 0, you get, good call, alright. Plus 8, that was a nice A, wasn't it?
Yeah.
Plus 1. Okay, so then you want to know the position at 1, so you find S of 1, and you get some answer, 16 thirds. I also probably would have accepted 5 1/3, but I'd have to think about that. S of 5 equals, you said 44?
Yep. Yeah.
Okay, so we're done. We did it all right. For those that did it that way. Anyways, so what if I asked you, did anybody do it a different way? This is the way I would have done it too. But what if I asked you, what about the integral of t squared minus 8 over t plus 1 squared from 0 to, we want to know at 1. So if I found the definite integral style, so it's 1/3 t cubed plus 8 over t plus 1 from 0 to 1. So I get, plugging in 1, I get 1/3 plus 4. 4 and 1/3, or 13 thirds. Did I do that right? Plugging in 0, I get 8. So 24 thirds plus 13 thirds, 37 thirds? What am I doing here? Oh, subtract. So minus, so there's the 1, gives me 13 thirds if I did my mental math. Minus, if I plug in 0, I get 8. 13 thirds minus 8, so 13 thirds minus 24 thirds is negative 11 thirds. So what the heck did I just find?
A number.
So what is the negative 11 thirds? What did we do? I mean, it's a number, but what does it mean? Is this when you say good question?
You gotta think this. You can't do anything. Hey Siri, what is 11/3? 11/3.
Say it again. So here. Okay, it's the displacement. Very good. So from time equals 0 to time equals 1, my particle along the axis is displaced negative 11 thirds. Can that help me at all get our answer of our position at 1?
Probably. I don't know.
Probably, and I don't know.
I don't know. I mean, they're somehow related, so there's a potential.
Okay, so let's go number line style. Where does my particle start?
At 0.
Well, no, when time is 0,
Oh, it's
where is my particle?
9.
It's at 9. So here I am at 9. That's at t equals 0. So then what happens for the next 1 second?
It goes backwards 11
It
thirds.
goes backwards 11 thirds. So now we're going backwards 11 thirds, which puts it where?
That's 16 thirds.
27 thirds minus 11 thirds is now 16 thirds, and that's when time is 1. So the integral of net change, the displacement, from 0 to 1, how has the particle changed? It's gone backwards negative 11 thirds, or gone backwards 11 thirds. This, when time is 0, we started at 9, so that means we ended up right here. So now if I wanted to figure out what's the particle, where is it when time is 5? I mean, we could integrate from 1 to 5 if we want to. We could integrate from 0 to 5. If I integrated from 0 to 5, what would I get? See if you can figure that out without actually doing the integral.
125.
Without, like, just using your logic number line. What am I going to get for this result right here? Nick says 35.
That makes sense.
It is 35. And how do we get 35, Nick?
To go from 9 to 44, you add 35.
Very good, because we know the position at 5 is 44. So if I'm going to start there, 5 seconds later, I need to be at 44. That means that's when time is 5. I better add 35. My integral is a net change, or my displacement in those 5 seconds has to be a positive 35. And we could do that and you would get 35. So if you wanted to figure out the distance traveled from 0 to 5, would that be 35 here?
Yes. No.
For you talking about total?
Yeah, so if I wanted to know if I was traveling, and this was in miles, did I travel 35 miles for the first 5 hours? So I heard a yes and a no. One of you is right.
Good. Yes.
Any thoughts with justification?
Well, does he go back left and then back right?
So that's what you need to figure out. Does he directly go to the right the entire time, he or she?
No, because it went backwards.
Right, so the first 1 hour he spends going backwards this way, right?
But how do you know that's when it stops? So, like, when do you know it's like not going negative anymore?
We don't need to know. We just need to know, is the distance in those 5 hours 35? How far is this right here?
35.
That's 35. And if we started this way, we're for sure going, if we're going to end up here, we're for sure going to go more than 35 because we've gone left a little bit. So the total distance would be more than 35. We could figure out what the intercept is and do the absolute value. That was just a question I thought of. Like, the distance is going to be greater than 35 because it's not equal to the displacement because we didn't go the same direction the whole time.
So would it be, like, would you add, like -2?
Yeah, and then just make it absolute value. Yeah, make it positive.
Okay.
And then you'd have to double it to get back to 0, right? And then add 35. Yeah. Oh, did you say times 2? Yeah. But okay. TOO. Okay. The only thing. So the only thing I'm going to talk about now, in addition to this, in 7.1. There isn't a lot to this. The force is equal to sum k times x, where x is a distance. And work is the integral of the force. So an example for that, let's say, so an example, let's say a force of 20, force is measured in like foot-pounds, right? Or Newton meters, or, yeah, because it's a distance, okay, so I'll say foot-pounds, so it's a distance and a weight or mass, yeah. Okay, so
Oh, I want trust and believe this thing.
Yeah, it's a new.
it's in newtons.
But I mean.
About
technically
foot-pound
it's-
newtons.
Yeah. Is it Newton in foot-pound?
Yeah, technically.
Okay, so that's easier than writing all that. We'll go in. So a force of 20 newtons, and let's say it's for 5 feet. Or 5 meters, sorry, we're in physics right now. Okay, so I want you to say what's the work for the first 3 meters. So we need to figure out what K is first. So that's just an algebra thing. So if F equals Kx and our force is 20, K we don't know, and X is a distance, so that's 5. So K here is 4. So if we found K, now we have our force equation. Our force equals 4x. You see that? You just plug that in for K. So if our force is 4x, and if we want to find the work, it's the integral of force, and it says the first 3 meters. So we would to 3 4x dx. What's that? 2x squared from 0 to 3 9/2 would be how much work. And that, maybe work is in Newton meters then. Is that true? I think that's true. Yeah, this is recording. I should sound smart. Maybe I should sound confident. Oh, joules?
Yeah, I think it's a jewel.
And I think, is joules the same thing as a Newton meter? Might be. I'm kidding. Okay, I'm going to stop. Any questions on 7.1 stuff? Okay, so just remember force equals kx. Use what's given to you to find the k, and then just integrate what you get for the equation based on how long you want to go.